Welcome. In this video, we're going to take a look at target costing. And that's going to afford us the opportunity to do two things additionally. One is to review our costing system, specifically in this case, activity-based costing. And also, this will allow us to reiterate the importance of when you're trying to solve complex problems, rather than trying to answer specific questions. I strongly advocate that you just try to figure out what's going on. You try to create as much information as possible, fill in as many gaps as possible. And once you've done that, you get your head around the problem and you're able to answer any type of question that's put towards you. All right, so let's get started. So the first thing we want to do is take a 30,000 foot look at this problem. And we see that we've got a manufacturing scenario here where we make an MP3 player. We've got a costing system that involves 2 cost categories and 6 cost pools. We're given information on what the total costs are for each one of those pools and categories. We're given some additional information down here on what our allocation rates are for each one of our activity pools. And then we're given some additional operational information down here. All right, then we look over here and we see that the issue here is that we operate in a competitive environment and we need to reduce our sales price. And in order to do that, we need to reduce our manufacturing costs. So this is a typical target pricing / target costing scenario. Specifically, we need to reduce our manufacturing cost per unit by $8 or more. And the first step that happens is you go out and you try to, this gets back to a fundamental concept about cost management. Cost management is resource management. And how do you manage resources? In other words, how do you drive down costs? How do you be proactive about driving down your costs while you manage your resources better? And how do you manage your resources better? You make sure that you're being effective and you're being efficient. Well, what specifically does that mean? To say that we're being effective means we're doing the right things. We're engaging in value-added activities. If we're consuming resources by utilizing activities that don't add value, then we need to seek to reduce and ultimately eliminate those activities. Once we've determined that we're engaging or we're doing the right thing, then we need to ask ourselves if we can do that more efficiently. Efficiency is a relationship between inputs and outputs. Efficiency and productivity are the same thing. So it's asking, how can we do what we're doing better? So the first thing you would do if you were trying to drive down your costs is probably ask, can we do the existing things that we're doing any better? They do that and they find that improvements in manufacturing or efficiency are expected to yield net savings of $1.50, and that's not going to be good enough. So ultimately what happens in a target costing scenario where you have to make significant reductions in your manufacturing costs is you need to go back and you need to look at essentially the design of your product and the design of your processes. This ties into the concept of committed costs and cost incurrence, and the idea that very early on you make decisions that commit you to costs that you will incur much later on. So if you wait till later on in the process to actually start trying to drive down the cost, all you're going to be able to do is make some minimal gains in efficiency because you've already locked in your processes and you've locked in your product design. All right, so how we're going to actually work this problem is we're going to work it as a straightforward costing problem, just like we did back in the early chapters in this course. So over here, we're going to cost our original product, and then over here, we're going to cost our new product, making some of this changes that are being proposed. So here's the issue we have, and here's some of the expected effects of the new design. So first, let's take this information over here, which addresses how we're currently manufacturing the product, and put it into this format right here. Here's our total cost for each one of our cost pools and cost categories. That's this information right here. This information right here, our input or our allocation rates for our activity pools. And then we've got some operational information here, testing time, rework percentages, so forth and so on. So all of these items in here that are boldface is data that is given to us. as we proceed in this problem, we'll be calculating additional information, and we can distinguish that between the original information that was given in the problem by the fact that it will be bold-faced. Okay, now if we come down here and we look at the proposed changes, then we can take that data and put that over here. And once again, what's bold-faced is, excuse me, what's bold-faced is data that is given to us in the problem. And so what we're going to seek to do here is we're going to seek to calculate as much information as we can, flush out the problem, and then we'll be able to address whatever questions that we have. So the first thing that I would do in this problem is I would take these total numbers and break them down into per unit numbers. And that's what we've done right here. And I've indicated those in red. Once I have the unit cost numbers in conjunction with information I already have, I can work out what these other numbers should be. So for example, let's take we'll take machining costs right here. We know that our total machining cost is $31,500. We know that our unit machining cost is $4.50. We know that our allocation rate for machine costs is $4.50. That was provided right there. Therefore, the amount of machine time that must be used, we can calculate to be 1 unit. Okay, let's take a look at another one, rework costs. We know that our total rework costs are $14,000, which works out to $2 per unit. We know that the input price of reworking is $20. We know that we have 7,000 units that we manufactured and that currently 10% of those need to be reworked. So we can work out what our input quantity is based on that 7,000 and that 10%. That would be 700. So the input quantity per unit would be 0.10 times the $20 allocation rate gives us our input cost per unit of $2, which gives us our total cost for 7,000 units of $14,000. So we do the same thing here with our ordering costs and with our engineering costs. Now notice up here I have these costs in italics. The reason for that is I don't have either pieces of data referring to what the input price is or what the input quantity is. All I know is that the product of those two things is $26. So at this point I got to make an assumption. So I can either assume that I'm using 1 unit of input quantity, in which case the input price would be $26, or I could have assumed that I used 2 units of input quantity, in which case it'd be 13, so forth and so on. Again, sometimes you have to make these kind of assumptions. There's no problem in doing so. If you're going to do it, my suggestion would be you make it as simple as possible. So the most simplistic assumption here would be to assume that that's 1 input unit. Therefore, the input price for that 1 unit would be $26. Okay, so as you can see, we have flushed out the best of our ability, drilled down into all of these numbers, and have a very comprehensive understanding of what our manufacturing costs are to manufacture the 7,000 units we're using. The 7,000 units. Now let's focus our attention on what we know about the manufacture of the new products given the proposed changes. We know that our material cost will be reduced by $2.20. We know that our direct manufacturing costs will be reduced by 50 cents per unit. We know that there will be a 20% reduction in machining costs. The little asterisk, I have a little asterisk here because machining costs, even though we're going to become more efficient with our machining activity, our total capacity is not going to change. So given that this is a fixed cost and we don't change that fixed cost, it's going to be unaffected. So even though we become more efficient, the actual cost is not going to change. This is an extremely important point regarding fixed costs. Remember, in our costing systems, when we calculate an allocation rate for a fixed cost, we are essentially treating that fixed cost as though it behaves like a variable cost. In other words, as activity or volume increases or decreases, the amount of cost allocated would increase or decrease. But that's not the reality. The underlying reality is it's a fixed cost, and it's not going to change unless we make a decision to reduce that capacity. So it's always a good thing to increase efficiency, But if we increase efficiency on a fixed cost or an indivisible resource, what we do is we create unutilized capacity. That's the first step. The second step would be to find a use for that capacity, either to eliminate it, in which case our fixed cost would be reduced, or to take that unused capacity that we just created and find an additional use for it, in which case our revenues would increase. Okay, so continuing, we see here that these proposed changes will reduce our testing time by 20%, will reduce the number of reworks down from 10% of total production down to 4%, and in terms of ordering, the number of units ordered is impacted by the fact that this product originally involved 80 components, in which we made 2 orders in the time period. But the redesign of the product over here has reduced the number of components from 80 to 50. Okay, so now our next step would be to take all this information and recost the manufacture of the 7,000 new MP3 players. Okay, so up here, we're assuming that there was no change to the number of units of direct material required. However, there was a reduction of, I believe it was $2.20. We're assuming that happens with the input price. Once again, to reiterate this point, these numbers right here are assumed. All that we know is that they must multiply out to that number right there. Using those same numbers over here, what we know is these two numbers multiplied together must equal that amount. All right, direct manufacturing costs, they were reduced from $4 to $3.50. In terms of our machining costs, even though we reduced the demand on this activity by 20% and the input price stayed the same, the total cost is not going to change because the amount of machining capacity has not been reduced. And once again, as I stated a moment ago, the only way that that cost would change would be to reduce the amount of capacity supplied. Looking at testing costs, we can see that the increase in the efficiency of our testing costs, or the redesign of our testing costs, reduced it from 2.5 hours down to 2 hours. In terms of rework costs, because we drove down our defect rate from 10% to 4%, we can see the impact that that has. In terms of ordering costs, because we reduced the number of components via redesign from 80 components to 50 components, we can see the impact that that has on our ordering costs. And down here with engineering costs, following the same logic we had with machine costs, that is unaffected. So over here in our total costs, you'll notice that both of those numbers are bold-faced, and that's to indicate that that was original information. And it hasn't changed because those are fixed costs, and the only way that those costs would truly go down, truly in the sense of reduced resource consumption, is if we reduce that excess capacity. Okay, so we're able to see now that we have total manufacturing costs $279,440 to make the 7,000 units. That works out to a per unit manufacturing cost of $39.92. So now we can come down here and we can analyze this. There's the total manufacturing cost of our old design. There's the total manufacturing cost of our new design. There's the reduction in our total manufacturing cost. If we look at the same information on a per unit basis, there is the unit total manufacturing cost under our own design, $45. There's the unit manufacturing cost under our new design, $39.92. So as a result of these design changes right here, we were able to reduce our manufacturing costs by $4.08 per unit. That, in conjunction with the $100.50 reduction in costs from improvements in efficiency, which is operational activity-based management, gives us a total reduction in unit total cost of $6.48. Did we meet our goal? Well, our goal was to reduce total cost by $8 per unit, and so we did not meet that goal. So what would we need to do? We need to go back to the drawing board and look at additional things we might be able to do that would have an impact over here. So what are some of those things that we could do? Well, let's take a look right here at machining costs. As we discussed a moment ago, even though we increased the efficiency related to this activity, we did not reduce that capacity. If we reduced that excess capacity that we created, that 20% of our existing manufacturing capacity, or we found an alternative use for that manufacturing, for that machining capacity, then that would have the impact, that would have a positive impact on our overall cost. So that would be one thing we might consider. If we look up here at direct materials, here the assumption is we got a reduction in our input price, but we didn't make any changes to how much direct material we made. Okay, if that were the case, then we could take a look over here and see if it was possible to find a way of reducing the amount of direct material utilized in the manufacture of a product. That might be one place that we would look at. Over here, our testing costs. Notice that what we did with testing is we improved the efficiency of testing. We didn't really look at the cost related to it. So that's something we might be able to do. And likewise, that's true for these two activities as well. Notice that their input price did not change, and that the changes that we proposed had to do with the demand that our products made on those resources. Okay, that's it for target costing.